topic for the day, simultaneous equations, numericals. So we will just have a look at the numericals, simple solving, but not the word problems. Word problems are in another video, that is simultaneous equations, word problems. These are like regular simultaneous equations solving. Okay, now you have done this topic in class 8th. We are going to develop this topic further in class 9 with little deeper sums and one new technique being introduced, that is the cross multiplication technique. But of course you will be needing the other techniques to solve the problems as well, which you studied in class 8 standard. Now simultaneous means you have more than one variable. So here we restrict ourselves only to 2 variables as per the syllabus, and degree also will be 1. So therefore it is known as simultaneous linear equations in one way. In linear, the degree is 1, and also there will be 2 variables only, because simultaneous can also mean 3 variables, but we have only 2 variables in our syllabus and degree will be 1. Okay, so that was a brief introduction of simultaneous equations. Recall that in 8th standard you have studied addition, subtraction, coefficients interchanged and multiplication. This you have studied. To solve a simultaneous equation, either you add the 2 equations and one variable gets eliminated and then you proceed ahead, okay, or sometimes subtraction will work. You will have to subtract the equations and the variable will get eliminated. Then you have coefficients interchanged. Of course we will see some of these sums. Coefficients interchanged, then there is a specific method to solve. You add both the equations, get a new equation, reduce it, then compulsorily you subtract both the equations, you get a new equation, reduce it, and again solve the 2 new equations regularly. And then you have multiplication, multiply first equation by 5 and second equation by 3 or whatever, that judgment is there. So this you have studied in class 8th. Okay, now let us take some good problems first, simple numericals based on this, and then we will go on to the cross multiplication technique, which has been newly added in the syllabus and it is quite important. Question 1. Solve for x and y. 41x plus 53y is 135. 41y plus 53x is 147. Now see, this is of the type coefficients interchanged. See, coefficient of x is 41. Here coefficient of y is 41. Here coefficient of y is 53. Here coefficient of x is 53. Okay, sometimes the sign can be changed, different, that's okay, but the magnitude should be the same. Here it is working out, so coefficients are interchanged. Coefficient of x is 41, here coefficient of y is 41. Here coefficient of y is 53, here coefficient of x is 53. So this belongs to the CI variety, coefficients interchanged. So how do you tackle this? Now this will be 41x plus 53y is 135. Okay, now you bring x under x and y under y. So we will write 53x first. But mind you, take care of the signs. Yeah, this is positive 53x, so we have written 53x. This is positive 41y is equaling 147. So we have identified this is coefficients interchanged variety. So how to solve x under x, y under y? Now compulsorily you will have to add the 2 equations. So this is how much? 94x plus 94y is equaling 12, 8 is 282. Let me write it neatly. This will be 282. Now there is scope for simplifying this equation. So you divide each and every term by 94. So that will be x plus y is equaling 282 upon 94. So that will go 3 times. So x plus y will be 3. Divide each and every term by 94. Okay, suppose if you can't divide each and every term by 94, okay, then you divide by something else, the highest common factor, you take it and you divide by that. It all depends how the numbers are arranged, So x plus y is 3. This is a new equation we have got. Keep it like this. You can even number the equations. Like this, you can call it Roman 1, Roman 2, Roman 3. Now, this is fine. So just keep this in mind, okay. Now we will have to compulsorily subtract the two equations. Compulsorily subtract. This is a technique. So minus, minus, minus. Now 41x minus 53x, how much? Minus 12x. 53y minus 41y. Look at the new signs. 53y minus 41y. That is plus 12y. 135 minus 147. How much? Minus 12. Now there is scope for reducing this. We will divide each and every term by 12. If you wish and if you are comfortable, you can divide each and every term by minus 12 also. So what will we get if I divide each and every term by 12? Each and every term. So this will become minus x plus y is equaling minus 1. This is our second new equation. Now we just need to work with these two equations. So let us write it here. X plus y is equaling 3 and minus x plus y is equaling minus 1. Now you remember here I had written addition, subtraction, coefficients, interchange, multiplication. What will work here? Addition will work here because if I add both the equations, one variable gets eliminated. X plus, I am using the addition mantra. X plus minus x. ये तो पहले से ही minus x था तो ये उड़ जाएगा. So addition will work here. So this will go away. We will have y plus y 2y. 3 plus minus 1. 3 plus minus 1 because this is originally minus 1. So that will be 2. So 2y is 2. So y will be 2 upon 2. That is 1. So y is 1. We can double underline this answer. So it is easy for the examiner to search from whatever you have solved. But we need to find the value of x. So y equaling 1, we can substitute either in this equation. Do not put it in the original equation. The numbers are quite big. I mean, if you put it, nothing wrong, but it will take time and it is more prone to errors. So better put y equaling 1 in this equation. So it will be, or the lower one, x plus y is 1. So x will be 3 minus 1, that is 2. Fine. So x is 2. So this is done. So we found the value of y as 1, x is 2. If you wish, you can put these values in both the original equations. You will realize that these values satisfy both the equations at the same time. Okay. And our answers are fine. This completes with your question 1. Question 2. Solve for x and y, or they will say find the roots of the equation. That way also it can be framed. Roots matlab the values of x and y in this case which satisfy the equation. So they will tell you solve for x and y or find the roots of the equation. 3 upon x plus 2 upon y equaling 10. Find 9y minus 7x is equaling 10.5 xy. Okay, now these are like product varieties, xy will come as a single gatha, single entity, somewhere xy will appear. So there are different ways in which you can approach. Fine, I'll show you what is easy for most of the students. Now see, the variables are coming in the denominator. So you can directly take the LCM and see let's see how do we tackle this. So first we'll work with this 3 upon x plus 2 upon y is equaling 10. Now you take LCM. LCM will be xy. So x is will be 3y plus 2x is equaling 10. Okay. This will be 3y plus 2x cross multiply is equaling 10xy. This is like xy variety. Okay. So keep that xy term on the right side. Other equation is normal, so no issues. But wait, there is a decimal here. 10.5 xy. Now this is going to create a problem. To work with 10.5 and all will be little tedious. So we can write this as 105 upon 10. That will work out, that if you simplify, it will work out to be 21 upon 2. Okay, so better do that. So fine, this is one equation we have got. 3y plus 2x is 10xy. So xy term you keep it on the right side. Now let's come here. This will be 9y minus 7x. 10.5 can be written as 105 upon 10. Just simplify, cancel by 5. Finally it will work out to be 21 upon 2 xy. Xy is in the numerator, of course. Now 2 can be taken here easily, no? So this will be 18y minus 14x is equaling 21xy. Oh, we have got a good equation. Fine. 18y minus 14x is 21xy. Now we have this equation, we have this equation. So what do? This equation we bring it here. Okay, wait. I will erase this. Now here it will be 3y plus 2x is equaling 10xy, and the new equation 18y minus 14x is 21xy. Don't get worried about this xy, it will automatically solve itself. It will take care of itself. Okay. Now see, y term under y, x term under x, that's important. In case if it was not like that, remember to rearrange it with appropriate signs. Okay, the xy term has gone there. Okay. Now what to do? If I add both the equations, will it work? Will any variable get eliminated? No. If we subtract, will any variable get eliminated? No. Then it is it coefficients interchanged variety? In the beginning what did we write? You remember? A, S, Ci and multiplication. Addition method, subtraction, coefficients interchanged, multiplication. So addition, subtraction not working, and if you see coefficients interchanged is not the case, then multiplication. So what is the best thing? Say, okay, this equation you can multiply by 6. If you multiply this equation by 6, throughout of course you have to multiply, but the concern is this will become 18y and there is already 18y here. So one term is equalized. Then we can see what is to be done, but at least one term is equalized. So if I multiply this equation by 6, this will come 18y plus 12x is equaling 60xy, and 18y, this equation I will copy down as it is equaling 21xy. See, you could have multiplied this equation by 7 also. Then you will get 14x and there is 14x here. So any one of the two terms you try to equalize, the x or the y variable. Okay, now what will work? Addition or subtraction? Ultimately you always bank on addition or subtraction in the end, as our last resort to see. Ending step में हमेशा वो ही आता है ज़्यादा करके. Subtraction will work. Yes, if I subtract throughout, 18y will get eliminated. So we put here minus. So now remember, we are subtracting throughout. So minus sign I will put. Here also minus. But already there is one minus. So minus into minus plus. Actually it is subtraction. I want to write here minus, but minus into minus is plus, so we are writing plus. And here what? Minus. So this will go away, whole term. Plus 12x plus 14x, this will be 26x. 60xy minus 21xy will be 39xy. Okay. Oh, duster has gone down. Now this I will take it here again. 26x is equaling 39xy. X and x you can cancel. That means actually there is nothing called cancelling x and x. We are dividing both the sides by x. Now here you be attentive to the concept. We are dividing both the sides by x because x cannot be 0. There is a law which permits us to divide both the sides of an equation by the same non-zero number. So here if I divide by x, here also I am dividing by x. So x and x can get cancelled because we are dividing both the sides by x because x cannot be 0 in this particular sum. Why? If x is 0, you will have 3 upon 0. 3 upon 0 not defined, equation cannot exist. Okay. So we can cancel x and x. Now this will be 26 upon 39 is equaling y. So y will be, we can cancel with 13, 13 2s are, 13 3s are. So y will be 2 upon 3. Isn't it simple? Now what is remaining? We have to find the value of x. For that you will have to, let's put it in any of the equations, whichever we find convenient. So y is clear, but the sum is not yet over. Also we need to find the value of x. Now I'll put it in this equation. This appears smaller, na? And I won't multiply it by 6. That we are done to proceed further. So this is 3y plus 2x is equaling 10xy. This equation we will take and we will put the value of y. So 3 into 2 by 3, because y is 2 by 3, which I am substituting it here, plus 2x is equaling 10 into x into y. So this gets cancelled nicely. 2 plus 2x is equaling 20x upon 3. We'll take it here. 2 plus 2x is 20x upon 3. Now it's a simple equation. Collect all the x terms on one side. So this is 2 and we are coming here now. This will be 20x upon 3 minus 2x. So 2 will equal, take LCM, 20x minus 14x, correct, no? 14x upon 3. Three into 2, 6. 6 is equaling 14x. So 6 upon 14 will be x, or x will be 6 upon 14. 2 3s are, 2 7s are. So x is 3 by 7 and y is 2 by 3. Fine, this is a good 4 marks question, not really difficult. So these type of questions you should be focusing on in grade 9. In class 8 you had the simple ones, right? Anything else? No, we are done. So this completes with your question 2. Question 3, solve. 3 upon 2x plus 2 upon 3y equaling minus 1 by 3. ठीक है. 3 upon 4x plus 1 upon 2y is equaling minus 1 upon 8. Here the variables are coming in the denominator. Okay. Here also they are coming in the denominator. There are many techniques. One is the substitution method. You remember? Put 1 upon x as a and all. That is also okay. But we can take the LCM easily. That would be easier approach. So what we will do is we will consider this first equation. I will take the LCM. LCM will be how much? 6xy, isn't it? LCM of 2 and 3 is 6 and LCM of x and y is 6xy. 6xy divided by 2x. 6xy divided by 2x. So that is how much? Correct, na? 6xy divided by 2x. So that will be 3y. That 3y will get multiplied by the numerator. So it will become 9y. Then 6xy divided by 3y. That will be 2x. So 2x will get multiplied with the numerator. So that will become 4x is equaling minus 1 upon 3. So let's put it in the refined format. We can cross multiply easily. 27y plus 12x is equaling minus 6xy. Okay. Do we have scope for reducing this equation? Yes. 3 is the highest common factor. So divide each and every term by 3. And notice this has turned out to be a xy variety product. So x into y, ek gattha aega. So that we will keep it on the right side. And other terms we will keep it on the left side. Similar to the previous sum. But we will divide it. This implies 9y plus 4x is equaling minus 2xy. We have divided each and every term by 3. Okay, so this equation is now smaller. Let's come to the other equation. Here we will take LCM, 4x and 2y ka LCM. Don't take it as 8xy. Na? 2 and 4, the LCM is 4. X and y LCM is xy. So this would be 4xy. So 4xy divided by 4x, y. This y will get multiplied with the numerator. So 3y. Then 4xy upon 2y. 4xy upon 2y. How much is that? 2x. That 2x will get multiplied with the numerator. 4xy, see what I have done is 4xy divided by 2y. 2x. This 2x will get multiplied with the numerator. So numerator is 1. So 2x into 1 is this. Is equal to minus 1 upon 8. Let's refine this, cross multiply. 24y plus 16x is equaling minus 4xy. Scope for reducing this equation further? Yes, this implies divide each and every term by 4. So this will be 6y plus 4x is equaling minus xy. Divide each and every term by 4. Okay, up to here we have come. Now this was our new equation for this and this was our new equation for this. Let's bring them close and see how to tackle them. So this I'll bring it here, okay, y under y now. 6y plus 4x is equaling minus xy. Fine. Now what will work here? What should we do? Addition, subtraction, so that one variable gets eliminated. Subtraction. If you add, nothing will get eliminated, you know. So subtraction. So this is minus. This is also minus. Again here minus, but minus into minus is plus. So 4x minus 4x, that goes away. Okay. And 9y minus 6y is 3y. This will get eliminated. Minus 2xy plus xy. minus 2xy plus, we have to deal with the new signs, minus 2xy plus xy, that will be minus xy. Now y and y will get cancelled. Cancelled means actually we are dividing both the sides by y, which is permitted because y cannot be 0 here. If y is 0, equation is not defined only. So here y can be anything, but it won't be 0. So in such a case, we are permitted to divide both the sides by y. And this will give you 3, because if y had the capacity to become 0, then we could not have divided both the sides by y. Now 3 will equal minus x, but we want x. So minus 3 will equal x. Okay, na? 3 will equal minus x, or minus 3 will equal x. Implies x is minus 3. Now y is still remaining. So x is minus 3, we can put it in this equation or this equation, whatever, that is left to you. I will put it in the first, this is 9y plus 4 into minus 3 is equaling minus 2xy. So minus 2 into minus 3, because x is minus 3, into y. 9y, this equation I am using it, putting the value of x as minus 3. So it will be 9y plus 4 into minus 3 is equaling minus 2 into minus 3 into y. Now this will be 9y minus 12 is equaling 6y. Easy, 6y you get it here, all the y terms, this will become 3y, 9y minus 6y, that is 12, y will be 12 divided by 3, so y is 4. So we have easily found out the value of y and we have found out the value of x. And this completes with question number 3, which is just appears to be difficult, but it was fairly manageable. Okay, so this completes with 3 good questions based on numericals of simultaneous equations, the deeper ones. Now we will go to cross multiplication method. Okay, these were all general techniques. Sometimes the board can specify, solve these simultaneous equations by cross multiplication method only. So first you will understand what is this cross multiplication method, and then take 2 good questions on it, and you will be done with this topic. Okay, solving simultaneous equation by cross multiplication technique, newly introduced in the syllabus. Now see, this actually banks on determinants, what you will study in standard 11th. But without going into the formal discussion of determinants, we will give you 2 ready-made formulae. But actually it goes on the idea of determinants only. But anyway, here, since we don't have determinants categorically in our syllabus, you can learn this ready-made formulae which will give you the values of x and y. Okay, see here x is taken as your variable. Say you have an equation 2x plus 3y is equaling 5. This is your equation. And then you have say 2x minus 3y is equaling minus 1. Consider these 2 simple equations. So when they say x, matlab it is the first variable, and then you have the second unknown, that is y. So this is the formula. I will tell you how to remember this. But keep one thing in mind, when we say x equaling, means x is one of the roots of the equation, y is the other root of the equation. Instead of x and y, if the equation is framed in m and n, then it's very silly for you to write x equal to. Then you will have to write m equal to. The first one m and the other one n. That way. If the equation is framed in p and q, then p will equal this and q will equal this. Got it? Okay. If the equation is framed in A and B, where A and B are the unknowns, then it will be A is equaling this and the second root B is equaling this. So hope this is clear. Okay. Now what is all this B1, C2, B2, C1? Very easy to remember. First let us see how to remember this. See, you start with B1. There are three things A, B, C. You start with B1. So B1 into C2. अभी 1 B के बाद क्या आता है? C. And this is 1, so this is 2. So B1, C2. It will never come the same B1, C1 like that. So remember, you start with B1, after B comes what? C. But B1 we have already taken, so we will take C2. Minus B2. Because now B1 is taken here, so here it will come B2. Here we have taken C2, so here it will come C1. Just ulta. Ulta in the sense, not C2 into B1, that would be 0 then. In algebra, A into B minus B into A will be 0. What I am trying to say is, learn this only, B1 C2 minus, this was B1, na? Now you write this as B2. And this was C2, you write this as C1. Over. The full thing divided by A1 B2. A1 B2. This is B, this is C, then this will be A, cyclicity. Like this. A, B, C. So B and C is taken, now we will come to A. Okay. This will be A1 B2 minus, abhi thoda ulta. This is A1, so here we will write A2. Here we took B2, so we will write B1. Hisab barabar ho gaya. Comfortable with this? So this gives you the value of X. Now Y. For Y you start the second root, you start with C. Here we started with B, here you start with C. So C1, A2. So how do you remember this? After C comes A, see like this. This is A, B and C. Now we have already, it goes like this. So C we have taken, so we will take A now. So C1, A2, now thoda ulta, minus C ko 1 diya, C1, so now we will write this as C2. And this is A2, so we will write this as A1. The whole divided by, no need to remember this denominator. Whatever denominator was here, same thing you copy here. The denominators will be the same in both the cases. So once you learn this, ditto transfer it here, over. This is the way you learn this. Now question arises, what is A1, B1, C1, C2? Okay. For purpose of example, you consider these two equations. Now though this method is very easy, but you have to set the equation in a proper form. In a proper form means first the x term, then the y term, the second root, and these constants also should come on the left hand side. And your right hand side should be kept 0 compulsorily. Otherwise this technique will not work. So let's first arrange these equations as per the need of the demand of the cross multiplication technique. So now what we will do, this will be 2x plus 3y, first x then y, minus 5 equaling 0. And here 2x minus 3y, this minus 1 will come on this side, plus 1 equaling 0. So keep the right hand side 0. First x, then y, then the constant term, and then the right hand side 0. Both the equations you have to put it in this order. Now it is very simple. This will be A1. 1 means we are pertaining to the first equation. That way you remember. What is the coefficient of y? 3. I mean positive 3, so no problem. This will be B1. So B1 will be 3. A1 will be this. And what is your constant term? 5? No. Constant term is minus 5. So this will be C1. because this is the first equation. So a1, b1, c1. So a1 stands for the coefficient of x, b1 stands for coefficient of y. Of course, the sign has to be taken care. Positive hai to positive, negative hai to negative, and c1 stands for the constant term. That is minus 5 in this case and not only 5. Now when we come to the second equation, this will be a2. What will be b2? Will it be 3 or will it be minus 3? Minus 3. This will be your b2 and the constant term is 1. I mean positive 1, so no problem. Plus 1 or 1 is the same. This will be your c2 over. Once you have identified this, just put it in this formula and you are done with the problem, no matter how much ever difficult the sum is, right? So it is quite easy, but the demand of this technique is that the equation should be arranged in a particular form. First x, then y, then the constant term, and the RHS should be, right hand side should be kept 0. Identify your a1, b1, c1, a2, b2, c2, plug in the values and you are done. You have found out the roots. X is one root, y is other root. Comfortable with this? So you could pause the video for some time, understand this, because now I will be taking two good questions based on cross multiplication technique, where it is specified solve using cross multiplication technique. So other technique will not be accepted if it is mentioned in the question paper, and it can be very much mentioned. Okay. Question 4. Solve using cross multiplication method. Solve using cross multiplication method. These two equations are given. Fine. Now if we realize many things are in decimals, we can work with this, but it is going to be very tedious. So we will have to refine these equations a little before we employ the technique. Now what we will do to get rid of the decimals, the first equation we will multiply throughout by 10. This is like a general thing, you know, I mean it's not a cross multiplication method, but before we employ cross multiplication method, we have to, you know, put the equation in a form which is like easy to work with. The coefficients are not some dangerous decimals. So first equation you multiply throughout by 10, that would be 4x minus 15y is equaling 65. Okay. Second equation also we multiply by 10, that will get rid of the decimal. Sometimes you may have to multiply by 100 also, but here if you multiply by 10, it serves the purpose. So multiply each and every term by 10. For the second equation also, 3x plus 2y is equaling 9. And what we had told you, before you employ this cross multiplication method, you should have x first, then y, and the constant should be on the left side and the right hand side should be kept 0. Okay. So now come here, this side, it will be 4x minus 15y minus 65 is 0. And here, okay, first x is there, then y is there. In case if y was first, then you put x first with the appropriate sign. 3x plus 2y minus 9 equaling 0. Okay, now we will have to identify a1, b1, c1, a2, b2, c2. So let's see that. A1, equation is in a proper form. A1 is the coefficient of x, so that is 4. Then b1 is the coefficient of y, that is minus 15. C1 is minus 65. Then A2. A2 means we have to refer to the second equation. Coefficient of x, that is 3. So A2 will be 3. B2 would be coefficient of y, that is positive 2. So we will write this as 2. And then C2. C2 is the constant term, that is minus 9 and not 9. C2 is minus 9. So we have identified A1, B1, C1, A2, B2, C2. Now we will employ that formula. Okay, we have written down the formulae for x and y. Now we will have to substitute. So this is a formula for x. We had told you how to remember this. Let's substitute B1 C2. B1 is minus 15, put brackets like this, into C2. C2 is minus 9. Now this amounts to only plug in the values. Minus B2, B2 is 2 into C1. C1 is minus 65. Okay, divided by A1 B2. Okay, minus A2 B1. Fine, we'll have to, now where do I do this? Okay, we'll take it here. I don't want to erase any formula. Now we will take it here. Minus 15 into minus 9, minus into minus plus. 15 into 9, how much? 135. This would be 2 into 65, 130. Negative into negative, positive. So plus 130 divided by 4 into 2, 8. Minus 3 into minus 15 plus 45. This works out to be 265 upon 53. Okay. Now see, with what can you cancel? Nothing is working out now. 53 is a prime number. Yes. Okay. So in such case, what is going to happen is this try denominator completely swallowing the numerator. Actually divide 265 by 53 and see what it comes. Is ending in 5. So possibly if I multiply by 5, 5 3s are 15, 25, yeah. This gives me exactly 5. So the value of x is 5, 265 upon 53. Comfortable? So x is 5. Now y also we will have to find out by this method only. See, mathematically it is not wrong if you take x as 5 and put it in one of the equations and find the value of y. But since it is specified cross multiplication method, you will have to find y also using that technique only. Okay, so this x is 5. Fine, now this I will erase. Now come to y. So y will be C1 A2. Where is C1? C1 is minus 65. A2 minus C2 A1. Where is C2? Okay. This minus comes because of the formula and C2 itself is negative. So minus 9 into A1. Let's see if we are okay. C1 A2. C1 A2. Okay. Divided by the same denominator. You can copy from the previous x provided that you have written it correctly. A1 B2. A1 B2 minus A2 B1. This will be 65 into 3. How much? 195, and negative into positive, negative. So that is minus 195. This will be 36, negative into negative, positive. So plus 36 upon, this will be same as before, 8 plus 45. This we shall now erase. minus 195 plus 36. What this will be? This will be 9. Okay, 5, 159. Correct, no? So this will be minus 159 divided by 45 plus 8, that is 53. Again see, 53 may completely swallow the numerator. 53 into 3 ending in 9, yeah, 159, and negative sign we will adjust. So this will give us exactly minus 3. So we have easily found the value of x and the value of y. You just need to double underline this. Now we will see one deeper question, little thought-provoking question based on cross multiplication method once again, and we are done with this topic. Question 5. Solve using cross multiplication method. This time equations are very different. 7 upon x plus 8 upon y is equaling 2, and 13 upon y plus 2 upon x is equaling 22. Fine, we have seen such equations before, but here we need to apply cross multiplication method. So we will have to first simplify this equation, refine it, but there is a problem. Before you jump to simplify, have little farsight. Just see, if you simplify, what will happen. You will take LCM like the previous sums. So it will be 7y plus 8x the whole divided by xy is equaling 2. So you will get 7y plus 8x is equaling 2xy. Now the problem will come of the type xy, that product. That's the problem. Here also you will have the same problem. 13x plus 2y is equaling 22xy. Now we need to take that constant term on the left side and keep the right hand side as 0, which will pose a problem because that constant term should not contain x and y. Like it should be a pure number, then this will work out to be 22xy. So that will create a problem. So what we do, here we will use partly substitution, convert it into a form where it can be solved by cross multiplication, okay, and then resubstitute. Let me show you what I am trying to say. Here we will write, put 1 upon x as a. And no need to write x as a. If you put x as a, what difference will it make? It will become 7 upon a. What's the value addition to it? Nothing. So put 1 upon x as a and 1 upon y as b. If you do this, this will become 7a plus 8b. Isn't it? See, 7 upon x can be written as 7 into 1 upon x, okay, and we have taken 1 upon x as a, so this will become 7a. Now it is okay. 7a plus 8b is equaling 2. Other equation, be careful, it is 13 upon y and 1 upon y is b. So second equation will become 13b plus 2 upon x, that is 2 into 1 upon x. 1 upon x is a, so that is 2a is equaling 22. Okay. These formulae have been written for the ready reference. Now we will have to arrange this. This is not in a proper form. You know, cross multiplication method says give me the equation in proper form and then I will work for you. Okay, so this will become 7a plus 8b, first root is a, second root is b, minus 2 equaling 0. This is 13b plus 2a, this we will have to take care. So this is plus 2a, I am not changing the value, this is plus 2a, I am writing plus 2a. 13b is positive because no sign before means it is positive. So 2a plus 13b, this we will take it here, minus 22 is equaling 0. Put the RHS as 0. Okay, now they are in proper form. What we need to do, we need to recognize A1, B1, C1. So what will be A1? 7. B1 will be positive 8. C1 will be minus 2. Now A2 for the second equation. A2 would be 2. B2 would be 13. And C2 would be minus 22. Okay. Now what is remaining? Just we have to plug in the values in this. So X will be B1 C2, that is 8 into C2, that is minus 22, minus B2, that is 13, C1 is minus 2. Make use of brackets, it will make things easy. Full thing divided by A1 B2. A1 is 7, B2 13 minus A2 B1. A2 B1. Minus 22 into 8. How much? 8, 16, minus 176. Negative into negative positive, so plus 26 divided by 13 into 7, 91. Be careful, huh? Here many people make mistake. 17 into 3, 51. 13 into 7, 91. Minus 16. This will be how much now? Minus 150 divided by 91 minus 16. How much it is? 575, correct? Yes, 75. So minus 150 upon 75, that is minus 2. Okay, but hold on, I have made a small error here. I have written x equal to. That cannot be written because the equation is in terms of a and b now. So like how we have written x equal to, x stands for the first root. Here which is our first variable unknown? A. So it's not correct to write x, we will have to write a equal to, because see initially it used to be x and y. So we used to write x is equaling this, y is equaling this. But now the equation is in terms of a and b. So we will have to write a equal to, that's important. Here also you will have to write a equal to and not x now. See, formula remains the same, but then we can't write x equal to, because the equation is in a. So a equaling this, and instead of y, which used to be the second unknown, our second unknown is b. So we will write b equal to. Okay. So a is now minus 2. But this is not our final answer. We have got the answer for a. Ultimately, originally the equation was in x and y. Na? So that needs to be taken care. Now 1 upon x is a. So we will write 1 upon x is a. What did we get a as? Minus 2. So 1 upon x will be minus 2. So minus 2x will be 1. So x will be minus half. So original equation में जो x है उसका value is minus half. Okay. Now what we need to do? We need to work out the value of b. Okay, so x is minus half is done. Now we will work out the value of b. That is our second root because the equation is in a and b. So we will use this now, b equal to. See, formula will remain the same. Instead of x and y, it will be a and b. If equation was in m and n, then this would be m equal to and this would be n equal to. Now b equal to C1 A2 minus 2 A2 minus C2 A1. So this minus comes because of formula, and C2 is minus 22. A1 A1 B2 A1 B2 minus A2 B1 equaling minus 4. We have just plugged in the values and now we are simplifying. 22 into 7, 154, negative into negative, positive. So plus 154, 13 into 7, 91 minus 16. This is how much? Positive 150 divided by 91 minus 16. That comes out to be 2. But mind you, this is the value of b. Ultimately, our target is to find y. So this we will erase now. X has been found out. Now, what was our substitution? 1 upon y as b. So we will write 1 upon y because our target is to find x and y of the original equation. 1 upon y is b. B has worked out to be 2. So 1 upon y is 2. So cross multiply, 2y will be 1. Y will be 1 upon 2. And this completes with your answer. Initially we found x some time back. Now we found y. Fine. So these are like some twisted problems based on cross multiplication method. So we have done 5 good questions from this topic, and this completes your topic of simultaneous equations. Only the numericals. Word problems is there in a separate video. Hope you liked and enjoyed it. Thank you so much.